Lesson 6.6, Inequalities in two triangles. All right, let's have a short demonstration here. Let's say I make a triangle, and let's say it's an isosceles triangle just for fun, like that. And we have another isosceles triangle whose sides are the same length as the other one. But notice the first triangle has a small angle there between the two congruent sides, and the second triangle has a large angle. What do you notice about that side? The small angle has a small side opposite, and the large angle has a long side opposite it. That leads us to the hinge theorem, which says if two sides of one triangle are congruent to two sides of another triangle, and the included angle of the first triangle is larger than the included angle of the second triangle, then the third side of the first triangle is longer than the third side of the second triangle, and that all sounds horribly confusing. So let's just have a picture. All right, this side's congruent to that side. This side's congruent to that side. It's important. Then we can compare angles between those sides. So the 40 is smaller than the 60. Opposite the smaller angle is a small side. Opposite the bigger angle is a big side. Similar to the big angles opposite the big side theorem, except for that was in a single triangle. This is in two separate triangles. For it to work, two sides have to be congruent to the other triangle, and we're comparing the angle between those sides. The converse of the hinge theorem is also true. If two sides of one triangle are congruent to two sides of another triangle, and the third side of the first triangle is longer than the third side of the second triangle, then the included angle of the first triangle is larger than the included angle of the second triangle. Again, the pictures. And again, we have two sets of congruent sides, and now we're looking at the third side. So the 10 is smaller, so this is a small angle. The 15 is bigger, so this is a bigger angle. So big angles opposite the big side. Let's try a couple examples. In this picture, PR equals PS, and measure of angle QPR is greater than the measure of angle QPS. So QPR is bigger than QPS. I'm going to put 2 marks on the bigger one and 1 mark on the smaller angle. That's just way easier to tell. According, though, our hinge theorem requires 2 sets of congruent sides. So we have PR and PS, but also PQ is congruent to itself. And then after you have that 2 sets of congruent sides and you know which angle is bigger, then the side opposite the bigger angle is bigger. So which one's longer? RQ. What if we go the other way? Let's erase what we have. All right, if PR equals PS, and again the PQ is congruent, RQ is smaller than SQ. That means SQ is bigger. So I'm going to put more marks on SQ than I put on RQ. That way we can tell SQ is larger easily. So after we have the other 2 sides are congruent, opposite the bigger side is the bigger angle. So which one's larger? It looks like SPQ. Oh, proof. Given AB is congruent to BC and AD is greater than CD, All right, I'm going to make lots of marks on AD and just a few on CD. That way we can tell AD is bigger. Prove measure of angle ABD is greater than measure of angle CBD. Well, of course, we start with a given. AB is congruent to BC, and AD is greater than CD. All right. Well, we want to have our bigger angle opposite our bigger side. But before we can do that, remember we have to have two sets of congruent sides. We only have the one set of congruent sides, so we need a second set of congruent sides. That would be BD. So BD is congruent to BD by reflexive. And now I have the two sets of congruent sides. I know one of the third sides is bigger. Therefore, if that's the big side, this is the big angle. Measure of angle ABD is greater than measure of angle CBD. What was that? That was the converse of the hinge theorem. Big angles opposite the bigger side. One more example. Two groups of joggers leave the same starting location heading in opposite directions. Each group travels 2 miles, then changes direction and travels 1 mile. Group A starts due north, so they go 2 miles due north, and then they turn 35 degrees towards the west. So that's 35 degrees. That was group A. Group B starts due south and turns 25 degrees towards the east. Which group is farther from the starting location? So in other words, we need to find this hypotenuse, or which one, I guess it's not a hypotenuse, we need to find this third side and determine which one's longer. Well, you'd say the one with the bigger angle. I don't know. We know that this side's congruent to that side because they're each 2 miles. We know this side's congruent to that side because they're each 1 mile. So it looks good so far. However, we need the angle inside the triangle. So I need this angle here. It is a linear pair with a 35. So it would be 180 minus the 35, or 145. So that angle is 145. This angle makes a linear pair with a 25. So it would make 155 degrees. So which one's bigger? The 155 is bigger. So that means that side is bigger. So which one is further? Group B is further. It has a larger angle inside the triangle, so it has gone the farther distance.